All right, welcome to Investigation 10A. This is about marine ecosystems and food webs. We will get to a point where we will answer some questions, but there's some terminology to go through, and I want to walk you through it, highlight some things, and make sure that you understand the vocabulary that we're going to use. It's vocabulary that you should hopefully be familiar with, not only from last year, but from your Unit 9 textbook pages. But I want to break it down and make sure that we're all on the same page anyway. So what I'm going to do is I'm going to read through it paragraph by paragraph. I know that's not the most exciting thing in the world, but we're going to do that, and then we're going to stop and make some notes, highlight some things, underline some things, that kind of thing. And the rule is whatever I ask you to do or whatever you see me do, you need to do also. That is part of the grade that you are earning, is that you're following along and that you're filling it in so that you have that information to go back to at a future date. Okay? All right. Well, first of all, it says, in a marine ecosystem, organisms interact with one another and with the physical conditions and chemical substances of their surroundings. The way organisms obtain new supplies of energy define their roles or positions in the ecosystem. An ecosystem consists of both living, biotic, and non-living, abiotic components. Biotic components include producers, consumers, and decomposers, whereas abiotic components constitute the physical and chemical properties of their surroundings. For example, nutrients, water, dissolved gases, water currents, and, of utmost importance, a source of energy, primarily sunlight. Okay, so let's break this down, make sure that you understand everything that is being said in this particular paragraph. All right, so first of all, remember that a marine ecosystem, that is not y'all's bell, that is the end of the school day bell, so just hang on. Okay, in a marine ecosystem, that first of all, that refers to ocean or water, okay, as opposed to a terrestrial ecosystem, and I didn't write it in because I want you to listen. A terrestrial ecosystem has to do with land, so please just write the word land in there. So if we're talking about an ecosystem on land, that's a terrestrial ecosystem. If we're talking about an ecosystem in the ocean, we're talking about a marine ecosystem. All right, an ecosystem consists of both living and non-living components. All right, so I'm going to take my green and underline the living or biotic components of my ecosystem. Biotic components include producers, consumers, and decomposers, whereas abiotic components, abiotic, remember, are non-living. I'm going to do that in red. Abiotic components constitute the physical and chemical properties of their surroundings. So what nutrients are present, how much water, dissolved gases, maybe water currents if we're talking about in the ocean, the amount of sunlight, and there are some other abiotic factors like temperature. Write that down so that I know you're listening. Temperature. Another one is salinity. And another one is pH, which is how acidic the water is. All right, in this investigation, we examine how marine organisms depend on one another as sources of food energy. Because the flow of energy within marine food webs is difficult to measure directly, scientists follow the transfer of biomass from one trophic level to another as an indicator of energy flow. Biomass is the total mass or weight of organic tissue present within living organisms. Okay, so make sure that you've highlighted the section that says scientists followed the transfer of biomass from one trophic level to another as an indicator of energy flow. Biomass is the total mass or weight of organic tissue present within a group of living organisms. Okay? After completing this investigation, we're going to be able to describe how energy and biomass are transferred within a marine food web. We'll be able to explain the significance of the relatively low ecological efficiency in the food supply, or in the supply of food energy at higher trophic levels. We're going to be able to list some of the ways that marine organisms depend on one another for survival and describe a coral reef marine ecosystem and its vulnerability to coral bleaching. All right, so I am going to stop this and do a new screencast, and we're going to pick up at marine ecosystems and food webs.